for the people that are here, do you have much experience with Dynamo? What's sort of the like, have you never used it? Have you heard it? Have you used it a lot? I guess where's everybody at? Maybe drop it in chat or just speak up if you want to. Just kind of curious.
I've been really interested in some of the design considerations of DynamoDB for a while. So I've used a little bit of it, but that whole single table piece, making the leap from relational to Dynamo is like, it's like this wall that I keep hitting up against. So
Yep.
Yeah.
Yep, for sure. Yeah, it's definitely very different than a relational database and hard to make that conceptual switch.
Hello.
Hello.
你在打电话？
No，
开会啊？
我看一个什么东西，那不能？你看怎么我在上面？
你投到那个。
All right, 27. Shall we start, Don?
Sounds good.
Okay.
Sounds
great. Okay, great. Thank you very much, everybody, for joining our workshop for this month. Right. So we have today we're very pleased to welcome Alex DeBrie from US. Alex is AWS data hero. In particular, he is expert in DynamoDB. So, and today he will be sharing with us on how to interact with DynamoDB APIs, like creating table, put or query data to the server, and so on. So it is really good chance, good opportunity to learn more about DynamoDB from the master. Okay. Right. So as usual, this session will be recorded, and then for everyone who missed something or you want to share with friends or colleagues, so we will post it later. All right. So Dahan or Paul, do you want to add something before we start?
I don't want to add anything. I just wanted to emphasize one more time. It is 1 a.m. in US, and Alex already said if I do anything wrong, I have an excuse. So don't be too hard on him.
Okay.
Grading on a curve here. Yep.
Good,
yeah.
good.
So I'm setting the bar low, Alex. So
thank you. Appreciate that.
Yeah, reduce some of the pressure.
Okay.
All yours.
Thank you, Dan. So welcome, Alex. Thanks a lot for your time. Really appreciate it. And then let's get started. Paul, can you hand over the host to Alex, please?
Sorry, I just fixed that. I just fixed that setting. So Alex, you should be able to share your screen now.
Gotcha. Okay. Let's see. All right. I assume you all can see. Oopsie, my slides.
Yes, we can see. At least I can see.
All right. Cool. So as mentioned, I think let's see, Gary or someone dropped the repository into the chat. So make sure you're there.
Yes.
Yeah, in terms of the setup here, I'll do a little bit of lecture. I'm going to try and keep that to a minimum, but I do want to like provide a little bit of background as we're working through that. Or is my hold on, my sharing is paused. Can you see? Are the slides changing? Can you see the DynamoDB on the slides, or is it just a blank screen?
It's just on the it's non-presentation view of.
Okay, hold on a sec. Let me get that back now. All right, now we're back.
Yep, this is looking good.
Okay. All right, sounds good. So I'll do a little bit of lecture, but again, I'm going to try and keep that to a minimum. Basically, make sure you have that repository open, and I'll do lecture. And then we've got 3 different lessons throughout the lecture. We'll learn to interact with DynamoDB a little bit. So, you know, if you have any questions throughout this, feel free to speak up. You know, don't hold back, because if you're not getting it, someone else probably isn't either. So make sure you ask questions. But with that, let's get started. Yeah, this workshop is about Amazon DynamoDB. So just a little bit of background about what is Amazon DynamoDB first. It is a NoSQL database from AWS. You know, NoSQL's kind of been more popular since mid to late 2000s. You've got things like MongoDB, Cassandra, DynamoDB, different things like that popping up. It's really used, I think, for two main use cases. And the first use case, and this is what really dominated and why DynamoDB was made at first, was for high scale applications, right? And this is, DynamoDB is actually basically like a productized service of something that was built inside Amazon.com retail, as they were having trouble, you know, hitting the high scale they needed for their, you know, Black Friday, Cyber Monday, Prime Day type applications on Amazon.com retail. And let's talk a little bit about why it's used for high scale applications. So I like to show this little conceptual chart about sort of DynamoDB versus other databases. And here on the x-axis, you know, I have data size. What happens, you know, your data as it gets from, you know, 1 gig to 10 gigs to 100 gigs and terabytes and more and more. And then on that y-axis, we have performance. You know, at the beginning, it's blazing fast, and slowly goes to fast and sluggish and painful. If you're working with a database like MySQL or a relational database, you might see a performance curve like this, where, you know, when you first release your application, you have, you know, 1 gig, 10 gig of data and not that many users, all that stuff. It really is blazing fast. Everything's hitting the indexes. Everything can be in memory. It's going really quickly. But as you start to get more data in there, it might go down to being sluggish, right? And now you got to do some investigation and say, hey, how can I make my performance faster in my relational database? You know, do I need to add more indexes? Do I need to denormalize a little bit? Do I need to drop some access patterns that weren't working? And then at some point, you might get to the point where you need to re-architect, right? You just have so much data in there where you can't be sort of churning through that, and it's harder to horizontally scale these relational databases. So you see sort of a performance curve like this with that relational database, where it just gets slower over time as your data grows. DynamoDB, on the other hand, has a performance curve more like this. It's going to be just completely flat over time. And you know, maybe it's not going to be as blazing fast at that very small data level. You know, maybe you can get something faster with the MySQL there. But the great part here is it's going to be consistently fast. It's going to be it's going to be single digit millisecond response times, you know, at 1 gig and at 10 gig, 100 gig and a terabyte and beyond. And you're going to get the same performance patterns in testing as you are in prod and down the road once you've scaled. So I think people really like that. Very predictable scaling patterns, understandable scaling patterns as compared to a relational database. So that was sort of the first core use case for DynamoDB, using for these high scale applications. But then in the last couple of years, we've had this serverless revolution, right? And DynamoDB has really been the database of choice for a lot of folks in the serverless world. And let's talk for a few reasons about why that's the case, because this is different than the high scale application use case. I think there are a few reasons people really like DynamoDB in a serverless application. Number one, because it's fully managed, right? If we're talking about serverless stuff, we have managed compute like AWS Lambda. We have managed API gateway. We have all these managed services we're tying together, and DynamoDB is really, I think, the ultimate in managed databases. You like really can't manage much of Dynamo yourself. It's totally provided to you as a service. You don't have to choose instance size, anything like that. You don't have to upgrade software. It's all provided to you just as a service, and you're just getting it that way. And it really is the most managed of databases out there. Second reason it's really popular is they now have pay-per-use billing, which is really just an amazing game changer if you think about your database, where you're actually paying, you can choose to pay by the actual reads and writes that you want, right? You're not paying for this pre-allocated chunk of compute and RAM and network and all that stuff. You can just say, hey, pay me for every single read and write I make to this database, which is pretty amazing if you think about it. And it works really well with that serverless system, right? If you're playing for your compute like Lambda by the use and API gateway, it fits really well in there. Third, it's very infrastructure as code friendly. So it's very easy if you're using tools like CloudFormation or Terraform, things like that, to integrate that into your application, which I think has really been popular in the serverless world as well. It uses IAM for authentication, which again, if you're using these managed services, managed compute, where it's got all your credentials in that Lambda function, it works really well. It's just like using, SQS or Kinesis or any other AWS service. Works well that way. And then it has an HTTP connection model, which I think was really important for early adoption with Lambda, where the long-lived TCP connection, a limited number of connections for like a relational database, was hard with Lambda, where you have this hyper-ephemeral compute where your compute's just sort of spinning up all over the place. It didn't work well with that relational system, whereas it works really well with Dynamo. You're just connecting over HTTP, just like you would any other service. So those are the big reasons Dynamo's taking off in the serverless world. And with that sort of background, let's move into the workshop section here. We're going to cover this in 3 different parts. If you've heard about DynamoDB, you might have heard about single table design and things like that with Dynamo. We're not going to get into that a bunch here. What we're really focusing on is hands-on usage of Dynamo, and like, what are the API interactions? How do I create a table? How do I read and write data from my table? So that's mostly what we're going to be focusing on here. I think the modeling concepts are less hands-on and more conceptual, and I do a lot of stuff with that. So you can check out, I did a few talks at reInvent on that. I got a few other talks. I've got blog posts, I've got the book, things like that. So check that out. This one, again, is mostly going to be hands-on type stuff, not as much single table design. But 3 basic lessons we're going to do here. Number 1, just starting off with some basic operations, how to create a table, how to read and write some data, things like that. Then we're going to learn about what's called a composite primary key and how this can really move you beyond simple key value access usage in Dynamo and into more complex access patterns. So if you're using Dynamo as your application data store, you're probably going to be using a composite primary key. And then we're going to talk about a concept called secondary indexes, which enable additional access patterns on your data. So who am I? I'm Alex DeBrie. I wrote the DynamoDB book. I also created DynamoDBguide.com. As Gary mentioned, I'm an AWS data hero and just a general AWS and serverless fan. Mentioned the book. If you want to go check that out, it's DynamoDBBook.com. It's just a comprehensive guide to data modeling with DynamoDB. So if you want to learn about single table design, all that stuff,
No.
go ahead and check that out. It's long. It's 450 pages. It talks about relationships, sorting, filtering, all that stuff. And it's got 5 walkthrough examples, including like the entire backend of GitHub, right? So we do like organizations, users, repos, issues, pull requests, stars, all that stuff. So go check that out if you really want to see how to model DynamoDB. And with that said, let's hop into the first lesson, which is basic operations of DynamoDB. I'm going to cover just a little bit of terminology in DynamoDB first, and then we'll hop into the actual part. This is the longest lecture part of the whole time is what I've done so far. I won't be talking at you this whole time, I promise. So yeah, let's start off with DynamoDB terminology. 4 main terms you need to know with DynamoDB, and those are table, item, primary key, and attribute. Going to walk through that with a little bit of an example just to get our bearings under us first. So let's imagine we have users in our application. We want to store information about users. We might have some data like this shown on the screen. I have 4 different users here. I have myself, Alex DeBrie, and a few folks at Amazon, Jeff Bezos, Jeff Barr, and Werner Vogels. If you look at all this data together, that's going to be called a table, right? So similar in some ways to a table in a relational database, different in other ways as well. But all that data grouped together is going to be called a table. If you look at an individual record in that table, that's going to be called an item. So outlined in red there, that's Alex DeBrie. That's my user item, right? It's going to have all these different data pieces all together, similar to a row in a relational database or a document in MongoDB. Now, when you create your table in DynamoDB, you need to specify what's called a primary key, and every item that you write into your table needs to have that primary key. And that item needs to be uniquely identified by that primary key too. So you won't have 2 items with the same primary key in your table. If we look at that here on the far left, I have that primary key highlighted. And this one, it happens to be called username. And you can see, I have Alex DeBrie, we have the Bezos, different things like that. But that's going to uniquely identify each item in your table. Again, you need to specify that up front when you create your table. In addition to that primary key, you can have other attributes on your item. So I've got those sort of outlined in red over there. You can think of those similarly to columns in a relational database. The big difference here is that you don't need to define these up front like you would in a relational database. DynamoDB is going to be schemaless, so it's not going to enforce your schema when you're writing items into that table, other than that primary key, which is required to identify your item. But all the other attributes, you can put them in there, but you don't have to. You can have different attributes for different kinds of items in your table, all that, things like that. So here we have first name, last name, email. Those are going to be attributes. Each attribute will be typed, and you can have simple attributes like strings and numbers, or you can have more complex ones like lists and maps and sets, things like that. Those are the four main concepts there. So now I want to hop into actual lesson 1. So go check out that GitHub repo and click on that lesson 1 and work through the contents there. And there are 5 basic things you're going to be doing in this first lesson. You'll be, first of all, creating a table and see what that's like to specify that primary key on your table, give your table a name, things like that. Then there's some sample data in that repository. You're going to write those items into your table, see what the mechanics are around this put item operation for Dynamo. Then you're going to read those items back, right, using get items. So we're going to see, it's a database. You want to save some items, you want to get them back out. We're going to see how to do that. And then next thing we'll do is use something called condition expressions to prevent overwrites, right? Because if there's already data in it, or if there's already an item with a primary key in your table, maybe you don't want to overwrite it, right? If there's already a username, a user that exists with this username, you don't want to overwrite them. So how do you use condition expressions to prevent that? And then finally, we'll delete that table and clean it up. So this will get us familiar with the very basics around DynamoDB. In the repository, there's examples for Node, but also, if you're using a different language, check that out. Make sure you just read the API docs and try to do it. But the examples are there if you do get stuck, anything like that. So with that, I would say let's take some time to work on lesson 1 together. I'll be here if you have any questions, if you want to drop them in chat or just ask questions out loud. Yeah, feel free to start working on that one.
So yes, everyone, if you have difficulties to find a repo, I write down the repo in the chat line. Please check on there. It's very easy to follow.
I've also just put the link specifically for section 1 in the chat.
Thanks, Don. Question from sorry if I butchered his name, Adharaj, earlier about is Dynamo similar to MongoDB? I would say very similar in a lot of ways. It's a NoSQL database. You'll see some similar concepts, especially around that primary key, access patterns, the schemaless design, different things like that. The scaling concepts are very similar between MongoDB and DynamoDB. If I had to say the 2 biggest differences between sort of Mongo and Dynamo, Mongo is going to be a lot more flexible in what it will allow you to do. It has more flexible query patterns that you can do, different types of indexes that you can do that DynamoDB will not give to you. And I think that's a philosophical difference between those. DynamoDB basically says we're not going to let you do something that won't scale at all. So if it's some sort of index or pattern or query pattern, anything like that, that's not going to work at 10 terabytes. Dynamo's mostly just not even going to let you do it. Whereas Mongo would let you do that, but then if it ends up not scaling very well, you're sort of on your own there. So you're sort of need to constrain yourself and say, hey, if I'm going to have a really high scale application, don't use this type of pattern or things like that may not scale. So I'd say those are philosophical differences. I think MongoDB wants to be more helpful up front, whereas DynamoDB really wants to enforce that structure that you won't hurt yourself later on. The other difference is just going to be in terms of sort of how managed it is, right? Dynamo, again, is just a service. There are very few knobs you can turn, and you just interact with it like a service, like you would SQS or S3. Whereas Mongo is more sort of like that server-based model of a relational database, things like that. So you might need to manage different servers and instances, things like that. There are hosted options on both MongoDB Atlas and on AWS itself using DocumentDB, but you still need to. It's more more similar to like RDS, where you're sort of managing the instances, that even if some of it's managed for you, whereas DynamoDB is sort of a black box. You're just reading and writing data in from it. You don't really interact with the underlying mechanics as much. I'll plan on giving maybe, I don't know, 15 or 20 minutes for this first lesson, and then we'll kind of review what we learned in this one, what we hopefully learned in this one, and then move on to the next one. But you know, if sort of everyone's done, or if we need more time, we can be flexible on that as well.
So Chandira has just asked a question. In DynamoDB, does it have one region capability? For example, if a client wants the database to be in one region only, say Australia, can we limit that?
Yeah, so when you create a DynamoDB table, you will create it in a specific region in AWS. So this could be in you know, the Sydney region if you wanted to, or it could be in US East 1, or it could be in EU, wherever. So you can choose the region you want to do there, and that can be accessed from clients all over the world if you want to. If you want to enforce the client itself being from a particular region, you'd need to do that sort of in your application layer itself. But then if you did, one feature that DynamoDB does have is one called global tables, to where you can have like an active setup, where maybe you create your table in the Sydney region, but you also want to have a active master in a couple other regions as well, and basically it's going to do bidirectional replication there. So say I had Sydney and US East 1, a client could write to either one of those, and it's going to get replicated over across to that other the table in the other region as well. So it helps spreading that out for you, but by default it's going to be in a single region.
Cool, thank you.
Yep.
If anyone does have any issues or any questions about the workshop, then do feel free to either speak up or just drop them in chat, and we can relay them to Alex.
Yep, absolutely. And again, it's the first time, so if something's not clear, please, it's not your fault, it's mine. So don't be shy. Okay.
Han wants to know, how does update work in DynamoDB? And also, do we have upsert functionality?
Yep, great question. We don't, I don't cover updates in this workshop, but there is an update item operation where you can update that, you know, individual attributes on an item. It does have upsert functionality. So if that item already exists, you can just be manipulating those attributes that are contained in your update expression. But if it doesn't exist, it will insert it into your table. And yeah, you can do some pretty nice stuff with the upserts. You can have you can use condition expressions, which we'll learn in this lesson. So you can assert some sort of condition before that update is applied, and sort of bail out on that update if that condition is not met. You can also do things like incrementing attributes. So if you have a number attribute and you want to do an atomic increment, you can do that in that update expression rather than having to like pull down that item, increase that value, and then sending it back as an update.
Cool.
Yeah.
Thank you.
Yep, good question.
Alex?
Yep.
If you feel comfortable, you can do the instructions on your desktop while sharing, so people can watch as well. That is one thing. If you do feel comfortable, but if you don't, I do have an more philosophical question overall for designing the table. So, when I was doing DynamoDB, we don't generally start from data. We generally start from usage patterns. So what kind of queries the user will need, etc. So the design of a DynamoDB is radically different than a design of a relational database. Can you talk a little bit about that, kind of how you approach a DynamoDB design when you go to a client, if you don't mind?
Yep, absolutely. Yeah, that's a good point. Yeah, accessing your data in DynamoDB is going to be a lot less flexible than in a relational database. So as you mentioned there, it's you're going to need to sort of design your table for your access patterns rather than modeling your data in an abstract way like you would in a relational database. Normalize it and have that, and then write the queries after the fact. So if I'm working on a table, a new data design, I usually go and say, first, make sure you understand your application really well and really dig into it and understand those concepts and how they work together. I say build out an ERD, so an entity relationship diagram, and say, hey, what are my different entities I have in this application, right? What are the boxes, and then how do they relate to each other? Do I have one-to-many relationships? Do I have many-to-many relationships? What does that look like between my different objects in my table? Once I have a good sense of that, then I say, actually list out the access patterns you're going to have on your data. And I say, get really specific here, right? So if you have create user, you have get user by username, get user by email address, maybe list users within an organization, things like that. Make sure you know your access patterns. And I would say actually list them out very specifically and write them down. And there are a couple ways you can go about that. If you're building like a REST API in a backend, you can just say, hey, what are the different endpoints I'm going to have here? What are the different options on this endpoints for filtering and sorting, things like that? But make sure you have all those listed first. If you're building an application that doesn't use a REST API, maybe go through the different screens, or if it doesn't have UI, just think of the different processing flows you're going to have, different things like that, and get specific with that. And then once you've done that, then you go through and design your table and say, hey, how do I handle each of these access patterns? And you actually just sort of write down, like, hey, this access pattern, I'm going to use a get item with these conditions to handle it, or I'm going to use a query with this, or I'm going to use a secondary index, which we'll get into later on with all that. And make sure you can handle it that way. So you're really designing your table to handle those access patterns that you've enumerated.
Thank you.
Yeah, cool. Got a few more questions. So, Adaraj, so when mentioning the type of each attribute, can we mention more constraints like required to be true or false, etc.? No, you can't. You can't mention that within DynamoDB itself. Dynamo is not going to enforce that at all. So Dynamo is going to mostly treat your data as opaque, other than that primary key that's required to be on there. So what you need to do is have that, you don't want to be schemaless generally, because that's gonna lead to madness. What you need to do is enforce that schema in your application, right? So if you're having an item come in, make sure you're doing strong validation on that before you read or write that out to DynamoDB, so that when you read it back, you can know sort of what you're getting back there. That's all going to happen in your application. All right, Oren had a question if I can share an example for a document that lists all the access patterns. I can. Let me pull one up, and then I will share that. Yep, Adderall. Yep, client-side validation, absolutely.
Alex, a quick question, another one from me again.
Yep.
So generally performance and costing, extreme costing comes for DynamoDB when people do not understand the difference between scan, filter, or query, the difference of those two things. So for a user, when we first develop your DynamoDB, when you have very small tables, the performance costing as well as the output of the scan and filter is very similar to query.
Mm-hmm.
So, I guess is related to my original question about designing DynamoDB with the query patterns in mind. Would you mind explaining what's the difference between scan and query in DynamoDB?
Yep, sure thing. And we'll get a little bit more into the conceptual stuff behind query a little bit later on, but I can give you a quick overview of what that looks like first. So a scan is going to be like a scan in a relational database, right? It's going to look at, it's just going to go over every item in your table. Both query and scan can only return a meg of results at a time, so then you're just gonna have to paginate through that. But imagine if you have, a table with a gig of data in it, which isn't even that much data, but if you're scanning through it, it's going to take 1,000 sequential requests to get through that, right? A meg at a time to get through that entire DynamoDB table. That's with that's if you're doing a scan. So that's not going to be very efficient for most operations, right? Usually you want to do more targeted operations. So again, we'll get into this with the composite primary key stuff, but a query, it's going to be working on a subset of your data within a particular partition key. And you could think of that partition key of just dividing your table down into more narrow groups, right? So if you had, I'll show an example here as I'm answering that other question about Oren's question about showing a document that lists the access patterns. I'm going to show an example for the GitHub example I have in my book. But basically, imagine, I have all these different repos on GitHub, and I want to find, a particular repo and its pull requests or its issues or something like that. That's where I would use that partition key. I would use that query to go just to that specific repo. Maybe it's this workshop repo that we're working on and grabbing all the issues for that. So I'm narrowing my request down to a specific repo rather than looking at the entire table itself. And that's what query is going to do. You're going to split your data into much smaller chunks using that partition key, and then it gives you much more targeted access on that. So query is going to be much more efficient when you use it in almost all cases. You want to avoid scans generally, except for in very specific circumstances, just because it's not going to work as well as you scale. All right, hold on. I've almost got an example. Oh, go ahead.
Talking about the partition key, I guess there's also a method to define our partition keys to avoid hot partition key for imbalance on the partition. Am I correct?
Imbalanced partitions?
Yeah, when we are designing our partition key or choosing our partition key.
Yep, absolutely. You need to be careful. You want to use something that's fairly high cardinality for that partition key to spread out access across your table. So you don't want to use, a Boolean, true or false, something like that for your partition key, because it really just divides your table into two buckets. You want to use something like user ID or repository or something like that to really split it up. You might have unbalanced partitions in some ways where some of it's going to have more. That's generally okay. They've done a lot of work to make that not as bad over the last couple of years, which is really great. And now really the only thing you need to worry about with having unbalanced partitions is if you have extremely high scale and you have a partition that's just that's so hot that it can't handle the scale. And that would be if you're doing basically 3,000 read operations or 1,000 write operations per second on that individual partition is where you need to start worrying about that, which, a lot of people aren't going to hit that scale to where, a lot of people won't hit that on their entire table, let alone on one single partition on their table. So usually not a huge issue, but that's the main thing you need to worry about.
Cool. Good to know. Thank you.
Yep. Okay, I'm going to switch which PowerPoint I'm showing just for a quick second. Okay, can you all see my screen with a it's a PowerPoint with like a chart of access pattern, index parameters, things like that.
Yep, that's visible.
Okay, so this is a little hard without a ton of background context, but this is an example from my book where we're doing like an e-commerce site, different things like that, and it's basically a deals site. But what you might have is a chart like this where you write down your access pattern there on the left. We have create a new deal, we have create a new brand, create a category, see the featured deals on the front page, see the features deals for a particular category, all that stuff. You list those access patterns down the left, and then you say, hey, what index or am I going to use to handle this? And I might use my my mouse. Okay, these ones are all using my main table. If I go over here, yeah, if I look on some of these other ones, I'm going to be using my global secondary indexes, things like that. I'm also saying, hey, what parameters am I going to be including in there? Maybe I might have some notes on this. You know, how you sort of structure and format this access pattern chart is up to you. But I think the important part is to make sure you're just listing out every single one of these, so that you have a sense of what you're going to be dealing with, and then like what's your index you're going to be using, what are the access patterns, any particular notes, all that sort of stuff to handle that. Does that help? Who was that? Was that Oren that asked that? Yeah, Oren, does that give you a sense of
yes, thank you.
Yeah, okay, great.
And Alex, you mentioned earlier about denormalizing. I think that's the key as well, right? Like majority of our data has to be denormalized when storing it in DynamoDB, and so there will be multiple rows of similar data but different primary key.
Yep, exactly right.
Yeah.
Yep, yeah. So yes, you will have to embrace some denormalization if you're working with Dynamo. And the big reason behind that is there aren't any joins in Dynamo like there are in a relational database. So you need to think about how to denormalize your data. You know, there are downsides to denormalization. Normalization is a great thing, right? So you're not repeating yourself, and you have nice data integrity and all that stuff. So you need to be careful about what that denormalization looks like, but it can take a few different patterns. Like you're saying, you might have some duplicated information across a couple different items. So you need to ask yourself, hey, is this data going to be changing? And if it does, how am I going to know that it's changing and updating in all the relevant spots? Another way you might have denormalization is you might have complex objects on a particular item or on a particular attribute, right? You might have a map or a list on an attribute, which you wouldn't do in a relational database. You'd normalize that out into a separate table, so you have sort of a scalar value for each attribute there. So you might do some denormalization that way as well. But yeah, great point.
Cool.
I'm gonna close out of that one and get back to sharing. Looks like some people making it through the stuff. I would say maybe 5 more minutes for the first workshop. And then we'll move along. If you didn't get through all this stuff, again, there are examples in the repo, so you can go back to it later on and look through some of that stuff. You can also just hit me up. I'm pretty available via Twitter, email, all that stuff. So look me up. Happy to walk through any questions you have sort of outside of this workshop as well.
Guys, sorry to interrupt. Jennifer, so probably you unmute your session because we can hear that you're typing. Thank you very much, Jennifer. Okay.
The typing sound is quite encouraging.
Okay, Alex.
It is good.
Sorry.
Cool. I'm going to go ahead and move on to just reviewing this one and then moving on to lesson 2, if that works for everyone. Again, if you have any questions or want to do that, you can do this outside of the workshop and hit me up. I'm happy to answer any questions you have there. So let's just review what we did in this first lesson, we learned some of the basics of Dynamo. You should have created your first table. So we had this users table. We were creating. We had some sample data. Created that table. Two things I want to call out when you're creating that table. Number one, that primary key, right? That's what you need to specify when you're creating that table. What's your primary key structure going to be, and declare that on the table. So hopefully you're able to figure that out. Additionally, you need to declare your throughput on the table. How much sort of capacity are you going to have on your table? And there are two different patterns, as it said in the workshop, of how you can provision throughput on your DynamoDB table. One is to actually use provision throughput, and you're saying, hey, I want this much capacity available, and you'll specify it in terms of RCUs, which are read capacity units, and WCUs, which are write capacity units. And this says basically how many read and write operations can I do per second on my DynamoDB table. And again, this is pretty unique how Dynamo does this, where you're sort of thinking about the operations themselves. You know, a read capacity unit gives you 4 kilobytes of strongly consistent data per second. A write capacity unit lets you write 1 kilobyte of data per second. But you're really thinking into the operations itself, rather than like, hey, I need 4 CPUs and 16 gig of RAM or something like that, right? And then trying to figure out how your operations translate into that. Here it's a lot closer to what you're actually thinking about. So you can do that provisioned mode. You can also do pay-per-use on-demand mode, where you don't have to think about provisioning up front. It's still RCU and WCU based, but what they'll do is they'll just charge you that on a pay-per-use basis as you go. So for each read you do, they'll charge you. Each write you do, they'll charge you. I recommend this for a lot of folks. It's actually, it's 7 times more expensive on a per read and write basis if you have fully utilized capacity. The problem is it's really hard to get fully utilized capacity, right? Especially if you're thinking about how your capacity change or how your usage changes over the day, over the week, things like that. So I would say for a lot of folks, it ends up saving a lot of money and just time if you're using that pay-per-use mode. If you do have a higher capacity, or if you do have a table that's doing a significant amount of traffic and you want to save some money, then you can look into that provision mode once you have a good sense of what your traffic looks like. But definitely look at that on demand. I think it's just so awesome to be able to use that. So in addition to that creating table, we also wrote and read some items back from the table. One thing I want to mention is when you're using that simple primary key, which we did here, which just has the one element, the partition key, it's basically just a key value store. It's nothing more complex than that. So if we look at, here's the data that we actually had in our table. We had those 3 users, myself, Brad Pitt, Serena Williams in there. If you look at one of those items, right, that partition key username, that's going to be the key. So that's Alex DeBrie. That's how you go access that data. And the rest of it is just a blob. That's the value you're getting back from it. So it's just basically a key value store if you're using that simple primary key there. That can be great for certain use cases, but if you want to use more complex applications, you're probably going to be using a composite primary key, which we're going to get into in the next lesson. But yeah, this is basically just a key value store with that simple primary key. The last thing we did there is use condition expressions. And again, this is going to be whenever you're doing a write operation, you can include a condition expression, and basically it's going to evaluate that before performing the write. So you can make sure you're not clobbering your data, or you're going to make sure you're not taking a bank balance below 0, or you can enforce other types of application rules and logic there. So make sure you understand condition expressions. I just wrote a blog post about this like 2 weeks ago, so go check that out. I think it's linked in the repo as well. So if you have any questions about those, drop those in the chat. I'm gonna keep moving on to lesson 2, but I can come back to any questions as well. So lesson 2, we're going to move into a composite primary key and the query operation, which we discussed a little bit as well. So let's talk a little bit more about the primary key. This needs to be specified on your table when you create that DynamoDB table. It needs to uniquely identify each item. There are 2 types of primary key, and the first type is what's called a simple primary key. That's what we just did in this last example. A simple primary key has one element called a partition key, and again, that gives us just that key value access in Dynamo if we want to. The second type of primary key is what's called a composite primary key, and it's going to have 2 parts. It's going to have a partition key, but it's also going to have a sort key, and this is going to give us a lot more powerful query patterns in our DynamoDB table. Just looking at a couple examples, here's an example with that simple primary key. This is that that example I was showing with our terminology before, very similar also to the data we loaded, but that it's got that simple primary key, just a partition key, a username gives us that key value access. Now, if you had a composite primary key, it might look something like this. So now the primary key, notice it has two elements, and I've got those same 4 users I had in that original example when we were going through terminology, but I've also split that primary key into 2, and I have a partition key of the employer and a sort key of the username. So now my primary key is made up of those 2 parts, and it's the combination of those 2 parts that make up my primary key. So when I say, so every item I need needs both of these parts, and it's the combination of those that's going to have that uniqueness requirement. So you can see up there, my employer DeBrie LLC, and my username is Alex DeBrie. The other folks, you can see that they all have the same employer, right? They all work for Amazon Inc. So it's not that the entirety of the primary key needs to be unique, right? You can have multiple multiple items with the same partition key, as long as the combination of partition key and sort key is unique in that table. So you can see here, even though a few of them have Amazon Inc. as that employer, they have different username, which gives them that uniqueness requirement. So that's a little bit about primary keys. We're going to move into creating a table with a composite primary key and seeing what the mechanics are like with that. It's going to be pretty similar to creating a table with a simple primary key. We're also going to load some sample data again. This time we're going to use batch write item just to get you some familiarity with that. So instead of writing items one by one with put item, you can use what's called batch write item to write multiple items in a single request, a little faster there. So you can see what the mechanics look like around that. And then the important part of this lesson, how do you read back multiple items with that query operation, right? In the last example, we saw how to use it as a key value store, get one item at a time. But what if I want to get multiple items back? I want to get multiple related items back. You can do that here with that query operation. So, so go check that out. Again, I'll give 25, 30 minutes, something like that, to work on lesson 2. If you have any questions, drop them in the chat or just speak up.
Hi, Alex. There's one
Yep.
question from Rowan. I think we missed up. And they said that within one account, can I separate my tables into groups or related schemas? For example, each application has its own set.
I don't quite understand that question. Could you elaborate on that, Rowan?
Yeah, I was just, as I jumped into my DynamoDB, I realized I already had some bunch of tables in there. And I was thinking that if I was building multiple apps under the one AWS account, that I might want to have a sort of way of separating which table belongs to which app. And I kind of thinking about it's probably tags.
Yeah. Yep. You could use, yeah. So you're talking like in the console, just so like an easier way to browse sort of groupings that way.
Yep.
Yep. Yeah. Tags would probably be your best bet there. Yeah. Otherwise, you're working on something like naming conventions on the table name, which then you need everyone to enforce. But yeah, I'd say probably tags would be your best bet. Yeah.
Thanks for that.
Yeah. By the way, is that Rowan Udell?
No,
Oh, different Rowan. Okay.
different Rowan. Yep.
Okay.
There's a few of us around now. We're taking over the
Yeah.
world.
Yep. Yeah. I was gonna say there's another Rowan I know that's writing a book on IAM, which I'm very excited to when that comes out. So
Yeah.
if you ever want to demystify how IAM works, make sure you check that out.
Oren has a question specifically on your other work, Alex. Does your expertise include other AWS DB engines like QLDB, Elastic, RDS, and so on?
I would say definitely not as deep. I know Dynamo the best, but I have a fair bit of experience with relational databases, with Elasticsearch for sure. I haven't done as much with QLDB itself. And then I've done, in a previous life, I was a data engineer, so I did some work with Redshift as well. So a fair bit, but not as strong in those other ones.
Cool.
Yeah. Oh yeah, and Paul linked to the NoSQL workbench for DynamoDB, which is a pretty cool thing to check out. It's a good way to model data, put some example items in a table, see what that data is going to look like as you're sort of planning out these access patterns. I use it a lot. A lot of the examples that I show of data in a table comes from that NoSQL workbench, which is a really nice tool, and it's a lot better than I used to do it in like Excel spreadsheets, and that was a lot harder to do. So make sure you check out that NoSQL workbench.
But there is a training course that I posted, and this is about I believe 12 weeks course, and the course is about exploring the advances of cloud computing for your business and fundamentals of AWS. So if you're interested, go talk to your managers and then get a registration and attend the course.
Nice.
They are not our sponsors, for your information, and we are not making any money out of this. It's just something recommended by one of our organizers, so it must be good.
Yep, cool. Thanks for sharing.
Hi, everyone. Thanks, Alex. I just wanted to call out that your reInvent sessions, the data modeling with Amazon DynamoDB, part 1 and 2, were a couple of the best sessions that I saw this year at reInvent, and that I recommend them for everybody. And you also called out in those sessions about the advanced DynamoDB ones, and they were really good too. So if people are liking this stuff in the lab, they should check out those as well.
Thanks, Colin. I appreciate that. Yeah, glad you like that. I can link those in the talk here. But yeah, those are going to get into more of like the single table design or like advanced sort of modeling concepts, which I think is the important parts of Dynamo, the hard parts of Dynamo. How do you think about modeling and things like that? I think the API is more straightforward, once you sort of get familiar with it, but the modeling is where you need to do a lot of the work. So make sure you check those out if you want some of that stuff, and I will find links for those real quick and drop them in the chat. I just dropped a link to the YouTube playlist. This is all the DynamoDB sessions from reInvent. So that has, I'd say, like 4 core videos. I have 2 of them: data modeling with Amazon DynamoDB Part 1 and 2, and then Rick Houlihan, he works for AWS and is basically the most advanced Dynamo expert they have there. He does 2 talks, so he has some advanced design patterns talks as well. So he has 2 of those as well. So check out those 2 or 4 modeling talks, and then they have a bunch of other really great ones as well about people using it and different things like that. So check those all those out.
Our focus this evening is to consider the specific needs of Year 9 students, to provide details of middle school learning and wellbeing programs and procedures, introduce key staff who have an important role in caring for your daughter and are your key contacts, and finally, but definitely not least,
There are a couple of people who've got something running in the background. So if you do have the television on or something, can you please make sure that you mute it? Thank you.
This executive has responsibility for leading middle school, providing vision and direction, and working with other teams within the college.
I think we'll do another 10 minutes or so on this one, if that works. Yeah, let me know if you need more or less time. How are people doing? Do we still need more time? Is it good to move on? Anybody still working? Don't be shy if you are. I think maybe I'll move on and if that works for everyone.
And do remember that if you need to, you can go back and review the workshop after the session, and you can also ask questions on our Slack channel.
Yeah, absolutely. Cool. All right, cool. So let's do a quick review of what we looked at in lesson 2. So again, here we were working with a composite primary key rather than a simple primary key. And I want to talk about why a composite primary key is important and what that partition key is really doing for you in DynamoDB. We talked a little about this with queries and scans earlier, but I think this is important context to know. So, so far we've been talking about DynamoDB. We think of it as this sort of monolithic table, but behind the scenes, what they're going to do is they're going to split your data up into these different storage partitions, right? And you don't need to worry about these partitions, these storage partitions. DynamoDB fully manages this, but I think it helps build out your mental model of what's happening with DynamoDB. So it's going to have these partitions behind the scenes. For every about 10 gigs of data, it's going to give you a new partition. So here, maybe we have 15, 20 gigs of data. We'll have these two partitions, partition 1 and 2. And now when a request comes into DynamoDB, this is what's going to happen. Let's say we're putting a new item into that table we've shown, and let's say we want to put in Andy Jassy, right, who now is the CEO of, or going to be the CEO of Amazon. So we say, hey, employer is Amazon Inc., username Andy Jassy. What's going to happen is that DynamoDB front end, this request router in front, it's going to hash that partition key value. So in this case, the partition key is the employer. It's going to hash that value and then figure out which partition it belongs to. So in this case, after hashing it, maybe it says it belongs to partition 1. And then it's going to go send it out to that partition and write it there. Now, the great thing about this is this scales really well if you add a third partition, or if you add 6 more partitions, or if you add 1,000 more partitions, right? No matter how big your table gets, this is going to be a nice efficient operation, because that first step there is basically an O1, a constant time operation. It's going to be hashing that value and then doing a lookup in a hash table to see which partition it goes to. So then, if you have 10 terabytes of data, right away, it's going to hash that value and get it down to a partition that has 10 gigs of data, where now you're working with a more manageable set of data. And that's how DynamoDB is able to provide that persistent, or that consistent, that flat scaling pattern that we talked about before. It's relying on you to sort of partition your data using that partition key to narrow it down to a smaller search space. So again, that composite primary key, the concept I like to think about of the mental model here is, imagine you had a bookshelf that's full of dictionaries, right? Physical dictionaries that have, words in alphabetical order. That partition key is saying, which dictionary do I want to get out of all those bookshelves, or all those books on the bookshelves? I want to grab a particular dictionary. I'm going to go grab that one. That's what that partition key is doing, helping you find the right dictionary you want to go to. And then the sort key, you can have conditions on that query operation on that sort key, and that's saying, which items do I want from the dictionary, right? So if you open up that dictionary, you can say, hey, give me every item before dog in the dictionary, or you can give me everything between dog and elephant, or anything like that. You can do very efficient operations on that dictionary itself, because it's ordered according to that sort key. So you can basically grab an item or a range of items very efficiently, just like you can do in a dictionary. However, you need to use that sort key in your query. You can't use other attributes. Just like in a dictionary, you can't go to a dictionary and say, hey, give me every word that ends in ing, or give me every word that includes some word in its definition, or that derives from Latin, right? Like your dictionary is not set up that way. The same way your DynamoDB table is not set up that way to filter on things like attributes other than your primary key. In addition to that, we also looked at batch write item is just a faster way to write a bunch of items to your table. It gives you a few different batch or some batch mechanics there. There are a few different, in addition to batch write item, there's also a transact write item. So batch write item, you can put up a bunch of items, they can succeed and fail independently. So if you put up 20 items, 18 of them could succeed, 2 of them could fail. You have to retry those 2 that failed. Whereas if you use transact write items, all of them are going to succeed and fail together. So if you put up a batch of 10, one of them happens to fail, all 10 of those are going to get rolled back and sent back to you. So we won't go deep into transactions here, but make sure you know the nuances there. All right, let's move on to the last lesson in this workshop. This is around secondary indexes, and this is a really powerful thing if you're using DynamoDB. And let's see why we want to use this, right? So let's look at that example we've had with our composite primary key. We saw that when you're writing that query, when you're doing that key condition expression, you need to include an exact match on that partition key. You can have conditions on that sort key, but basically you need to use that primary key to handle your access patterns, just like we were doing with our simple primary key, right? We had get item was using that primary key. So it's very efficient to query and filter with that primary key. But what if you need to query with something else, right? These attributes, it's hard. You can't actually in DynamoDB efficiently query on those attributes, right? What if I want to access by my users by email or something like that, rather than their employer and their username? And that's where secondary indexes come in. They basically allow you to enable additional access patterns on that same data. So let's talk a little bit about what secondary indexes are. Basically what you do is you declare a secondary index on the table as a whole. And what it's going to do is when you declare the secondary index, data from that base table is going to get copied into this secondary index with a new primary key. So when you go to your table and you create a secondary index, you're basically going to be specifying a new primary key for that secondary index, new attributes, all those things like that. And then every item that you write into your base table that has those attributes you've specified for that secondary index primary key are going to get copied into that secondary index. Now that copying is going to be asynchronous, so it's eventually consistent when you're working with these secondary indexes. For the most part, tiny caveats there, but generally that's how you should think about it. Is this going to happen asynchronously? Now on that secondary index that has this copy of your data, you can do read-based operations. You can do queries and scans on that secondary index. You can't do write-based operations on that secondary index. So it's just like a view on your data almost to enable these access patterns. Can't do any writes on that. And there are 2 types of secondary indexes to think about, global secondary index and local secondary index. You're almost always going to use global secondary index. I'm not going to go into it in this workshop because it gets kind of into some nuances, but almost always use global. If you want to know why, you could Google, global versus local secondary index in Dynamo. I've got a post, Dynamo's got a post on this. So check out some of the basics behind that. So with that in mind, we're going to move into this lesson 3, and we're going to create a table with a secondary index. It's going to use the exact same data that we had in our last one, but have a different look at it so we can query it in different ways. And then we'll use that query on that secondary index to see how we can change up and enable additional access patterns with that secondary index. So with that in mind, go ahead and check out the lesson 3. Gary just linked to it in the chat. Yeah, and if you have any questions on it as you're working through it, let me know.
Alex, I have 2 questions. And when I was going through DynamoDB a long time ago, reading the documentation, you mentioned every partition has 10 gigs, right? Every partition has a 10 gig limit.
Yeah. Yep. Yeah.
Yeah.
Sorry. Go. Yeah. Go ahead. I'll let you finish your question because there's like some caveats. But yeah, go ahead.
Okay.
Yep.
So let's assume every partition has 10 gigs for this purpose of this question. And let's say hypothetically, I have a partition key which has more than 10 gigs of data. So is the partition split into 2 parts? This partition key split into 2 partitions, or can it not handle any partition key which has which stores more than 10 gigs of data? That's question 1.
Cool. Do you want me to answer that one, or do you want to answer?
Yes, please.
Okay. Yep. Sure. So Yes, a particular partition key can have more than 10 gigs of data. They'll split it across multiple partitions in that case. So I wish they didn't use the name partition, because it does sort of confuse with partition key, because a partition behind the scenes can have multiple different partition keys located on it, multiple different kinds of partition keys on it. It's not like it's going to have a partition per partition key, but also if you have an item collection, which would be all items with the same partition key, that's more than 10 gig, it would be split across multiple partitions in that case. The one caveat there, I would say, and this is why I almost stopped you before, but like if you have a local secondary index on your table, then they have a hard limit that you can't have basically all the items within an item collection with the same partition key cannot exceed 10 gigs. And that includes both your base table and your local secondary indexes. But that's one of the reasons I don't recommend using local secondary indexes, because of that caveat. But other than that, there's not a 10 gig limit.
Okay. Coming to the second question, I guess that's a very good leeway. Now, there are lots of problems with local secondary indexes. I'm not going to go into that. But what's the cost indications of the global secondary index? Is it like twice as much expensive, or is it, how does it compare?
Yep. So you'll need to provision capacity for your global secondary index separate from your main table, right? So if you've provisioned 10 read and 10 write units for your main table, you also need to provision some for your secondary index. It's basically going to depend on how much traffic you're doing against that. So, it's only going to get an item will only get replicated to that secondary index if it has the attributes specified for that primary key. So if those attributes are on every single item in your table, then it's basically going to be twice the write cost, because it's going to replicate each one out there. With the caveat that you can choose to project only certain attributes too. So if you have an item that's large, but in your secondary index you don't need all the attributes on it, you can say, hey, just project the username and the address, but don't project all the other stuff. And if that sort of brings you under some size limits, that can be less writes. So that could be less. And then the read capacity side, it's just going to depend on how many reads you're doing from your secondary index as compared to your base table. But yeah, I would say generally the writes are going to be 2x your cost, or not 2x, but because you could have multiple secondary index, but each secondary index you add is going to basically add that base table cost again, unless you have a sparse index or unless you're doing some projections there.
Oh, okay. But just curiosity here, local secondary indexes do not have that additional cost, right? Because it's not replicated.
Well, so local secondary indexes will use capacity from your base table. So in that case, you basically just need to, you're still going to use that capacity. It's just you need to do it on your base table rather than on your local secondary index. Okay. One thing that's theoretically nice about that is if you had maybe 3 local secondary indexes and they had different access patterns, you could maybe share capacity across them. In reality, that's pretty rare. And also the downsides, I think, from local secondary indexes
overweighs the benefit.
Yeah. Yep. And just quickly, downsides for folks who we want to talk about, and one we just mentioned is that it has that 10 gig hard limit. You can't exceed that. If you try and write to an item collection that has 10 gig already, it's actually going to reject that for you. That's a big one. Another one, you need to specify local secondary indexes when you create your table. You can't add them later down the line, which can limit your flexibility that way. And then the third one is the partition key for your local secondary index needs to be the same as in your main table. So it's basically like if you're still sort of chunking up your table in the same way across these different partition keys, but you just want a different sorting or organizing mechanism for that, then a local can be useful. But it also limits you quite a bit because often your access patterns don't have the same partition key. So those are the big downsides. The big benefit of a local secondary index is that you can get strongly consistent reads from it, which you can't get from a global secondary index.
Thanks, Alex. I wish you were here 3-4 years ago when I was reading all these documents.
Oh man, it's interesting. I think One thing I'm happy about is like the community around Dynamo is getting a lot better because, you know, I mean, 3 years ago, I didn't know very much about Dynamo. It was basically Rick Houlihan who was sort of doing all this stuff. And now enough people have been using it, I think, especially for that serverless use case, that it's just been growing and people are understanding the benefits more and the patterns to use rather than sort of just bringing over relational patterns. But yeah.
Thank you.
Oren says, what are the top 3 items in your wish list for missing features in DynamoDB? Let me think. I used to have a good set of these. Oh, nice. One of them that I wish they had a little bit smarter update operations. I wish they had something more like Redis. I think Redis, in terms of some of the operations you can do on your items. So the example I would do is like with Redis is sometimes you might have a list in Redis and maybe you want to push something to the end of a list, or sorry, put something at the front of a list, but also trim the list. So you have like an array that always has 5 items in it or something like that. And you know, if you push something on the list and now it has 6 items, you can also trim it as part of that operation. I don't know, Redis has like a bunch of sort of interesting things like that where you can update these items in sort of nice ways without having to like pull the entire item back, manipulate it, and then write it back to Dynamo. So I wish they had a little more flexibility around that stuff. There's one, like, this is very basic, but batch write item, which we used in lesson 2 there, has some limitations. You can't do condition expressions with batch write item. You can't do a few other things with batch write item that I wish batch write item was basically just an aggregated version of put item. Anything you could do with put item or you can't do update items when you're doing batch write item. So I wish it was just a sort of aggregated version of all these individual operations, but you just put them in a single request. I wish they had a little more power around batch write item. They just there's a feature called DynamoDB streams where you can basically get a change log of every write that happens to your DynamoDB table, which is really nice if you're doing change data capture. Maybe you need to put it in a data warehouse, or maybe you need to broadcast it out because you have other microservices that care about data changes in this service. They've had that feature for a while. One limitation of the original DynamoDB streams implementation is you can only have a maximum of 2 consumers from that DynamoDB stream, which could limit some of your downstream use cases. One feature they just came out with is you can use Kinesis streams as your DynamoDB stream implementation, which means all that stream data goes into Kinesis, which allows for more consumers, allows to sort of 5 standard consumers, or you can do even more if you're doing enhanced fan out, which is getting kind of deep in the weeds. But I think that really helped a lot of folks where they want to do stream, but they want to have more consumers that could handle that stream. So I think that was really nice for folks. I think those are the big one. Another really nice one that they just had is S3 export, where you can basically say, you can click a button and say, hey, export my entire table to S3, it'll be in JSON, and then you can query it with Athena or whatever you need to do with it that way. Because it's really hard to do sort of big aggregation queries, if you're doing like internal analytics, things like that. It's hard. You can't really do that in Dynamo. It's going to be inefficient. So having a way to sort of dump your whole table to S3 and then use Athena on it, huge win. I'm really excited about that one. I think that's great.
I think they're also working on putting the Lambda in between DynamoDB and Athena to direct integration at some point. There are some how-tos. It's not a feature yet. This is just something people said. Yep. You can do it if you really want to query DynamoDB from Athena. That's nice. Yep. There is other thing that I like about DynamoDB is the caching service that they have, which is even faster than the DynamoDB itself. So never used it, never needed it, but it's also there for the multi-region stuff that you want to speed up the stuff.
Yep. Yeah, that's a great point too. DynamoDB Accelerator DAX, that's that cache you're talking about. Really nice stuff, gets you very fast stuff and kind of unique caching stuff in terms of how it handles updates and all that stuff. It's really cool. And then, yeah, if you're running into, we talked a little bit about partition limits earlier. If you're doing 3,000 reads per second from a single partition, you can use, DAX in front of that to alleviate some of that pressure. So yeah, I'm trying to think if I have any other. They've done a great job in the last couple of years. The on-demand billing was just a huge change, and then also they've just done a bunch of work where it used to be if you had kind of unbalanced partitions and like a lot of data in one partition or a lot more reads and writes from that one partition, you sort of wouldn't take advantage of your throughput as well. And they've just handled that really nicely and really made modeling a lot easier to where that's not a concern for a lot of folks anymore.
Alex, there's a question from Oren. What are your top 3 items in your wish list for missing feature in DynamoDB?
Yep, that was the one I just mentioned. A few of those around like the Redis-like operations, the batch update item stuff, and then a few of the things that probably would have been wish list items, but they've recently improved those: the stream stuff, the S3 export, the on-demand. So yeah, I don't have a huge long list of that right now. I think they've done a really nice job around some of that. I'm trying to think what else.
I guess DynamoDB, this is not part of this session, obviously, but while we are talking about things, I got excited. Sorry. The one good thing is actually if you need more from DynamoDB, you can put an AppSync in front of it, so it will start making join kind of operations on DynamoDB and all sorts of fancy stuff that DynamoDB does not support out of the box, but can be achieved by putting a GraphQL AppSync in front of it. So those are also very interesting patterns. I start to see.
Yep, absolutely. All right, cool. 2 more questions came in. So, Oren, what is your recommendation, CloudFormation or Terraform, for creating DynamoDB tables? I would say that one probably more depends on sort of what you're using already. If you're using Terraform already for other parts of your application, I'd just say keep using that. Same with CloudFormation. I tend to do more work in the serverless space, and I think a lot of the serverless tooling is more based on CloudFormation. So I used to work for Serverless Inc., who has the serverless framework, which is based on CloudFormation. There's also AWS SAM, Architect, Arc.codes, just CDK, different things like that. So if you're doing a lot of serverless stuff, that's tended to be more CloudFormation based. So I've been using that, but I think there's not a huge difference between the two, and more just about what you're already using. Adi, can you throw some light on making GraphQL work efficiently with DynamoDB single table design? So yeah, this sort of feeds in with what Dagan was saying as well. It's oops, sorry. It's tricky. Yeah, this is kind of a nuanced discussion. So one of the parts about sort of single table design, which we didn't get to in this, but if you want to look up other posts I have or the book or things like that, it goes into that in depth. One of the patterns you might be doing with single table design is arranging your data in such a way that you can use that query operation to get multiple different types of items in a single request. So you might use that to sort of emulate joins, right? You have a parent item, and then you have some related items below it if you have like a one-to-many relationship, and you can put those all in the same partition and get that in a single request. And it's sort of a way to pre-join your data and make that happen efficiently. So you might see some patterns with that with single table design. And then there's a question on how do you make that work with GraphQL? And GraphQL is tricky because it doesn't quite just the nature of how GraphQL works, where you have, the resolver and then some nested resolvers, different things like that, and it sort of processes them in order. It doesn't quite work as efficiently to get that. Yeah, sorry, there's some nuance here, but so I would say some of the single table design stuff, if you're going to use GraphQL just sort of in a vanilla way, some of the single table design might be overkill in terms of that pre-joining stuff. I think a lot of the single table modeling principles are still important and worth looking at and understanding with Dynamo, but it's something like the pre-joining stuff might not as work or be as useful. One thing you can do if you do want to make use of that pre-joining stuff is you could do like a look-ahead query or something like that in Dynamo or in your GraphQL resolver, where you're saying, hey, if they're getting the GitHub repo, and you can get like issues or pull requests or some related item on that as well. If they're also pulling the pull request, if I look ahead to a nested resolver, I say, hey, they're also getting that, well, then I could make that query up front in this parent resolver and sort of pass it down to that nested stuff. So you can do some of that stuff. Some people say look ahead's an anti-pattern. Some people say, hey, do it anyway. Yeah, it sort of depends on how you want to do it. But I'd say there is a little bit of a conflict there, where Dynamo wants you to have known access patterns and model for that. And then GraphQL wants to give you flexibility on the client and say, here's how that data is modeled, and you can have flexibility around that. And then there's a clash on how that works. And it's not saying you can't use Dynamo with AppSync, or with GraphQL, but it might just say some of the modeling stuff won't be as useful for you with GraphQL. That was kind of long-winded, but did that make sense, Adi? Any, I guess, follow-up to that or anything?
I think my take on that one is, if you want, I mean, this is common for anything, right? If you want high performance, itsy gritty stuff, then you need to go to the if you want to use every single bit on the metal, then you need to go to the DynamoDB single page design with the indexes, global indexes, etc. But if your access patterns or data is not that important, or speed is not that important, or size is not that big, then GraphQL will give you some pretty good out-of-the-box usable tables. For example, I am using right now the Amplify framework, which builds the DynamoDB and resolves behind the scenes automatically. But it turns out it creates a different table for every entity you put into the GraphQL schema. So it's something that I wouldn't do if I was going straight with the DynamoDB, but it is convenient for me at this stage because I really don't process terabytes of data in a millisecond.
Yeah.
So,
yeah.
I guess that's where it comes down to.
Yep, absolutely. And also, I think, where something like Amazon or like the really high scale use cases, a request might come in and it might fan out to a bunch of different services that need to gather all this data and then return back. And if you have, one of those nested calls or services is also making like 4 sequential calls to Dynamo, like that's going to start slowing things down all the way up the chain. But if you're building a sort of an endpoint that is like the sole part of a request and it has to make 2 or 3 sequential calls to Dynamo, it's not the end of the world. I think like Dagon's saying, like understand your use case and your needs and like where you can sort of follow some of the strict performance stuff and where you can be more flexible with it. I think is worth knowing. Like Amazon and Uber, they have different needs than I have in my applications. So just be willing to understand that.
I think one important thing is that if you put, as you said, Alex, if you put GraphQL in front of DynamoDB, since resolvers can do multiple calls, it might not be as efficient. There is a really hidden cost, and as you said, the load that's coming with the resolvers if you are not very careful. Again, use case, but if you are doing high levels, high amounts of transactions, then GraphQL can get really hit the DynamoDB a lot.
Yeah.
Hence, the cost might increase quite drastically without you knowing what's going on behind the scenes. So that's another thing.
Yep.
I think it's also important to keep an eye on.
Yep.
So
absolutely.
Alex, before you go on to something related to this, Adi again, an extension to my doubt. So now, in this case, would you recommend, say, a REST call for any high performance request access pattern directly, and then for flexibility, all other calls may be GraphQL? So you have two endpoints. With kind of a pattern would work, better for any problem like that?
That could work. Yeah, it sort of depends again on your needs, and also like, if you have say you have a high performance endpoint, is it gathering lots of sort of different types of data that you want to assemble? So maybe you're not even having like a traditional RESTful schema where you're getting like one type of resource, but if you're gathering like a sort of a blob of different types of data, yeah, maybe you could optimize that in a particular way where it's going to be pretty efficient. If it's more sort of REST-like, where you're just getting, a list of resources or something like that, like that's probably going to be a pretty efficient GraphQL call as well. It's just like if you had a GraphQL call that was pretty big and gathering, users and repos and information all about that stuff, that could be in GraphQL a bunch of different requests to where you're like, hey, if that's a common access pattern for you, maybe it would be better to put that in a different sort of dedicated endpoint, like you're saying. Yeah, I would say in a lot of places, I'm sort of anti-complexity, so I'd be like worried about having those two different systems like that. But if it made sense for like what you're working for, I think that could be a good solution. Yeah.
Yeah.
Parvana, what's your recommendation for creating backups? An example would be when we need to keep the records of all updates. So I think I'll answer that in two ways. So backups generally, Dynamo has a couple different backup options. Number one, you can sort of do like ad hoc on-demand updates. You can basically, click a button in the console, or you can say, hey, make an API call that says make an update right now, and it'll basically take a snapshot of your table as it looks at this very instance and put it in, keep it in Dynamo for you, and you can restore a table from that backup at any time. They also have what's called point-in-time recovery. So you just enable point-in-time recovery on your table, and it's just continuously backing up your table as it goes. And then you can say, hey, I want to restore my table as it looked, last Thursday at 12:32 and 45 seconds. You can do it like that granular if you want to. So you can do sort of recovery to a particular second if you want to. So I recommend using that point-in-time recovery just because it's generally going to be cheaper because it's sort of always continuously backing up for you. The second part of that question is an example would be if we need to keep the records of all the updates. So if you need sort of like a change log of every update that's happened there, you could do that in two ways. You could keep the update information as like a separate item in Dynamo itself. I probably wouldn't do that, but there are some patterns for like if you have versions of data and sort of like here's the latest version, but here's all the like different versions it's gone through. You could do something like that. You could also use that DynamoDB stream, which I touched on a little bit earlier, to basically, you'll get every write operation in Dynamo. So if you're inserting an item, if you're updating an item, if you're deleting an item, you're going to get information on that stream. You could consume that stream and just write it out to S3 or something like that, and then you'd have all your updates forever if you want to do something like that. Did that answer your question? I'll probably give about 2 more minutes for this lesson 3, and then we'll summarize that and the whole thing. But yeah, happy to answer any other questions we have as well. All right, we good? Anybody still working? Want a few more minutes, or are we good to move on? Starting to lose my voice a little bit, so bear with me. Cool. I'm gonna go on here. So yeah, just a quick review of what we learned here. We looked at how secondary indexes work, and I just want to walk through with a model of our data to see what we're enabling here. So here's our data, our sample data that we used in both lesson 2 and 3. It's got that movie actors and movie roles table here. And we saw that it's very easy to use that query operation and say, hey, give me all the movies for Tom Hanks. And I could do that. I could get back Castaway and I could get back Toy Story. But one thing I can't do is go over here in that sort key and say, hey, give me all the actors that were in Toy Story, right? I don't have the actor name, I have the movie name. I can't do that access pattern because again, in my query, I have to include the partition key, and this is gonna cross partitions and it's not the partition key that I want. So that's what secondary indexes do, is they give us these additional access patterns on our data. So if we go to that table, we'll create this secondary index that just swaps the values in that primary key. And when you're doing a secondary index, it doesn't have to be a swap like this. You can use any attributes you want in your table, but I'm just using this one here to do that swap. So then it's going to look like this. And again, this is the exact same data that we had in our table. It's just reshaped in a different way and made accessible in that secondary index using that query operation. And now I can go to that query. I can say, hey, my partition key is Toy Story. Give me all the actors that had a role in Toy Story. And I can do that very quickly and efficiently. And that's going to enable those additional access patterns for you, which is great. So yeah, that's what secondary indexes do. Again, you can only use these for read-based operations. So you can't write directly to a secondary index. You have to do that on your main table. So when you're thinking about write operations, think about what information you're going to know when you're writing that data to make sure that's included in your primary key for your base table. Summarize just what we talked about overall here in the workshop today. We went through 3 different lessons. So we started with basic operations, created a table, saw what that was like, creating a primary key, specifying throughput, things like that. And then we wrote data to our table, read it back with put item and then get item. We also saw how to use that condition expression to make sure we're not overriding items that already exist. Second, we looked at composite primary key, because that simple primary key is only for simple key value type access patterns, but composite primary key, that's going to really open you up and allow you to do relations and more complex access patterns. So we used that composite primary key, saw how to use that query to get a bunch of items with the same partition key, put some conditions on the sort key if we want to. And then third and finally, we looked at secondary indexes, right? Adding the secondary index to your table to enable these additional access patterns, enable more read-based patterns as you need them. There's a lot more in Dynamo, right? Like this, again, was really just getting familiar with the API, but there's a lot of modeling stuff you can do. So you can do relationships in Dynamo. You can do one-to-many, you can do many-to-many, anything like that. You can do transactions in Dynamo. So if you want to operate on multiple items in a single request, you can use that transaction operation, which is a really nice feature they added, I believe two years ago now. You can also do some nice filtering, and it's pretty interesting what you can do with Dynamo if you really learn what's going on there. It's going to be different than in a relational database, but you can really do some nice efficient filtering that's going to have that nice flat scaling pattern that we talked about, where the performance is going to be consistent at 1 gig as it is at 1 terabyte. So any question? I'm happy to do a few more questions here. We got another 10 minutes or so. Otherwise, you can find me around. I'm on Twitter is probably the easiest way to find me. But find me on LinkedIn, email, my blog, all that stuff. If you want to know more, check out the book. That's going to have a lot more of the modeling stuff for you. But yeah, I'll also check out the reInvent videos that we talked about earlier as well. So yeah, any final questions?
No questions, but a comment. It's a very humble book title. The DynamoDB.
It's the only one.
Love it.
Yep.
Thank you.
Thanks, Audie, for the kind words on the book, and thanks for the support. Appreciate that.
Thank you very much for taking some time out and being here at 1 in the morning. It's greatly appreciated.
Yeah,
and
absolutely.
thank you for the wonderful workshop too.
Yeah, thanks for having me. It was a lot of fun to put this together, different than other ones I've done. So it's been it was a fun experience.
We do have a question from Kevin. If we have to update a large data set, how do you run the update if it's going to take a long time?
Yep, great question. Yeah, if you need to, add new attributes to existing items or manipulate it in some way, you're going to need to basically do a scan and update operation. The sort of the way I would think about it, if you wanted to do it in like a more serverless managed way, would be to use like probably a step function, right? Where you're iterating through this table, keeping track of where you are using that pagination token, updating these items as you go. So I would use something like that if you're doing it. You could also do it on a fleet of EC2 machines or something like that. It depends sort of what your compute is normally like for something like that. The one thing I would say about if you're going to be doing a large update or a large read too from your table is we talked about the scan operation, how you can read all the items from your table. You can actually do what's called a parallel scan. So if you wanted to break it up across 10 workers or something like that, there are parameters you can pass into the scan operation that allow you to do that in parallel very efficiently, where you're not sort of keeping track of all this stuff. They're going to help you keep track of that parallel scan. So make sure you check that out if you do need to do a scan. But yeah, depending on your compute, it's either going to be a bunch of EC2 machines or a step function if you want to use something like Lambda to handle that big update.
Cool. Thank you very much.
Okay.
All right. So Alex, thank you very much for your time. It was a very interesting session and workshop. And I hope, and I believe everybody of us learned something new today. And then if there are any more questions, if not, then yeah, we run out of the time. And then yeah, we can break up this session. And for every one of you who would like to contact to Alex, please do so. And I also put the LinkedIn link and Twitter in the line in the chat line. Right, Alex. Thank you very much for your time. We know that it's very late over there, and I hope you have a good rest after this.
Sounds great. Thanks a lot. Thanks for having me. It was great. Yeah, really appreciate it. It was fun.
Okay, thanks a lot, Alex.
Thanks a lot, Alex.